En 2 minutos vamos a comenzar, a la 1:10. Gracias.
Antes de comenzar este acto, me permito atender a las normas de la universidad en materia de protección civil. Les pido a todas las personas presentes que en caso de alguna emergencia que nos obligue a evacuar el auditorio, se dirijan sin correr, sin gritar y sin empujar hacia las salidas de emergencia que se encuentran detrás de ustedes y a mi lado derecho. Los puntos de reunión están ubicados en el jardín, a la derecha de este edificio y frente a la cafetería central. Se deben tomar las escaleras y no utilizar el elevador. Se les solicita además tener especial cuidado con los niños y personas con alguna discapacidad. Cualquier apoyo pueden acudir con el personal del ITESO. Y sin empujar hacia las salidas de emergencia que se encuentran detrás de ustedes y a mi lado derecho. Los puntos de reunión están ubicados en el jardín, a la derecha de este edificio y frente a la cafetería central. Se deben tomar
Buenas
las
tardes a
escaleras y no
todos. ¿Me
utilizar el
escuchan bien
elevador.
ahí?
Se les solicita
Buenas
además tener
tardes,
especial
bienvenidos
cuidado con los
y
niños y personas con alguna
agradecemos su
discapacidad.
presencia.
Cualquier apoyo
El día
pueden
de hoy
acudir con el
estamos
personal del
reunidos en
ITESO.
este evento, esta conferencia, que es parte del Tour de Conferencistas Distinguidos de la Sociedad de Comunicaciones del IEEE. Estos tours de conferencistas distinguidos es un programa que tiene el instituto a nivel mundial y la doctora Michel es parte de este selecto grupo de científicos de carácter de prestigio mundial y dentro de los cuales nosotros como capítulos, en este caso Guadalajara, Monterrey y Morelos, seleccionamos que nos visitara, pues solicitamos a IEEE Mundial que nos visitara la doctora Michele Nogueira por el tema en el cual ella es una experta, que es la ciberseguridad. Este DLT nos fue autorizado el mes pasado desde Nueva York y pues estamos ahora muy felices de contar con la presencia de la doctora Michel. Agradecemos a ustedes su presencia y esta es una conferencia que está siendo organizada por el IEEE Sección Guadalajara, que a propósito nos acompaña el presidente de la sección, el doctor Josh Aguilar, presente. Y también por el Vice Chair de IEEE Comsoc, Steven, está ahí al fondo. Y se hace en colaboración también con con Women in Engineering, con la doctora Mildred, que es la Chair de Sección Guadalajara. Sin el apoyo de la universidad, sin el apoyo del ITESO, en especial de los profesores del Departamento de Electrónica, Sistemas e Informática, esta conferencia no fuera posible hoy aquí en nuestras instalaciones, en especial por el coordinador de Ingeniería en Ciberseguridad, el doctor Luis Fernando, y también por los investigadores de los posgrados, está el doctor Villalón, y también nos acompañan catedráticos de la Universidad de Guadalajara, con quienes tuvimos también una charla previa a esta sesión. Bueno, sin más, pues comenzamos. El doctor Luis Fernando. Para quienes no conocen quién es el IEEE, el IEEE es el Instituto de Ingenieros Eléctricos y Electrónicos, conocido como el Institute of Electrical and Electronics Engineers, y estamos presentes en más de 160 países. Alrededor de todo el mundo somos más de 400,000 miembros afiliados, de los cuales el 30% son estudiantes. Aquí en el ITESO tenemos la rama IEEE, la rama estudiantil, y nuestro presidente es Jorge Isaac, que está ya a cargo en cabina. También nos están acompañando otros de la rama estudiantil de aquí del ITESO. En el IEEE estamos organizados en sociedades técnicas. ¿Puedes regresar una, por favor? Estamos organizados en 38 aproximadamente sociedades técnicas, que no es otra cosa más que el agrupamiento de personas que tienen un interés en común. La sociedad de comunicaciones es una de ellas, es decir, ahí estamos agrupados todas las personas que tenemos intereses alrededor de las comunicaciones y de las redes. El IEEE es un organismo mundial, de alcance mundial, que está dividido en 10 regiones. Nosotros somos la región 9, que va desde México hasta Chile, Argentina, termina, y también algunos países del Caribe. Digo algunos porque Jamaica es el único país del Caribe que no está incluido, porque él está asociado a la región 1.6 de Estados Unidos. Como verán, a esta región le llamamos la 9 Latinoamérica, y este es un DLT organizado para Latinoamérica. Ok, la sociedad de comunicaciones tiene una misión y una visión muy claras. Me gustaría que la leyeran junto conmigo. La sociedad de comunicaciones del IEEE promueve la innovación tecnológica y fomenta la creación y el intercambio de información entre la comunidad técnica mundial. Brinda servicio a sus miembros para el avance técnico y profesional, además de foros de intercambio técnico entre profesionales tanto de la academia, la industria y de instituciones públicas. ¿Y cuál es la visión? La visión es reunir al mundo en armonía a través de la investigación, la aplicación, la educación y la incubación de nuevas ideas en tecnología de redes y comunicaciones. Abajo está la página de Comsoc por si gustan también informarse más a detalle. Gracias. La que sigue. Ok. Atendiendo a estos intereses de la comunidad, en este caso de la comunidad Latinoamérica, interesada en el tema de la ciberseguridad, es que hemos traído esta conferencia a la cual hemos acudido el día de hoy y que será impartida por la doctora Michele Nogueira. ¿Que sí? Ok. La doctora, voy a poner mis lentes, por favor. La doctora Michele Nogueira es profesora asociada del Departamento de Ciencias de la Computación de la Universidad Federal de Minas Gerais, en Brasil. Recibió su doctorado en Ciencias de la Computación por parte de la Universidad Pierre et Marie Curie en la Universidad de la Sorbona, en Francia. También estuvo en una licencia sabática en la Universidad Carnegie Mellon en los Estados Unidos. Sus intereses de investigación incluyen las redes inalámbricas, la seguridad y la confiabilidad de las redes. En la actualidad, su investigación se centra en la creación de inteligencia de seguridad de red respaldada por la ciencia de datos. Ella es pionera en abordar los problemas de supervivencia de las redes inalámbricas llamadas autoorganizadas, siendo una de sus contribuciones científicas más destacadas en este tema. La doctora Michele Nogueira también se desempeñó como presidenta del Comité Técnico de Internet de la Sociedad de Comunicaciones de IEEE y como broche también es senior member de la ACM y del IEEE. Entonces, pues sin más, demos la bienvenida a la doctora Michele. Muchas gracias.
Buenas tardes. Esto es un gran placer de estar aquí. Yo no hablo español, pero yo voy a continuar en inglés. Pero it's my pleasure to be here. I'm very happy. It's my first time here in Mexico at all. So I'm having a very great time. I was in Monterrey yesterday, and here also in Guadalajara I'm having a very good time. I just have many food. So I will talk about data science for cybersecurity. This is just a little bit of the research that we do. And I expect that you at the end have an idea of the possibilities in terms of research that we can do in this domain. It's a very exciting part and subject, at least for me, and I hope to motivate you also to work on this area. I will not talk about specifically on cybersecurity. I will talk to you about something that is very hyping in terms of using data science. That means how to use data to have what I call security intelligence, that how can we help to the solutions in terms of security to improve with all this analysis and all the artificial intelligence techniques that we have in the literature. So I will start, I like to start my talks with some contextualization, because then we can understand how we just came up in the points that we are right now. So here I put this illustration regarding to the different industrial revolution. If we see here the first one with all the mechanization and the water power that gave us some improvements in production, then we evolved with the massive production and the assembly line and all the theories, like the Ford theories, the Ford theory that it could improve the production of in general, not only specifically for in this specific example by cars, but in general that what we have until today. Of course, the electricity here played a very important role in this aspect of production. And then we evolved with the electronics and improving in terms of computing and the miniaturization of these devices that allowed us to have computers everywhere as we see today. So we have now the computers everywhere that we can imagine, and automatization of many of the activities that we have. So we have these links and the connection between these devices that allow us to do things that we could not imagine before, and in a very easy way. Just imagine a few years ago, we needed to go to a bank, stay online for hours maybe, so to do some transactions. And today we can do this just in a few seconds. So this is just one example that we could evolve and we could do things or more things and produce more in terms of how we address things in general. Of course, this is not for granted. There is another side that I will show you very briefly, but just to have a perspective in terms of where are we going, we think that we are going to this fourth industrial revolution, where we will have really an integration of these devices in what we call cyber-physical systems, where or cyber-human systems, where we have these devices integrated everywhere in a ubiquitous way, and in a way that we can produce more data, more information if we can address the data. We have the self-cars, we have robots, intelligent robots, or we will have. We can edit the genetic in the sense, and this will cause a very dramatic transformation in terms of society in general. This is one aspect. So all these things bring us to technologies, as you see here. I put some few examples, like autonomous cars, the augmented reality, Industry 4.0. So those are, together with those examples, things that we can do, or we already can do, but the idea is to have this more and more ubiquitous in our day by day. So when we check the internet for the trends, one thing that that calls our mind is ubiquity. So every time more we have this ubiquity in terms of devices that we use. We have this diversity in terms of devices, like we have devices with very, they are very powerful in terms of resources, but also we have devices very small and very constrained in terms of resources. Here I put some examples from this variation, and also different devices in terms of where they will be, how they will be connected. But the thing is that this brings us to produce or generate more and more data. And this is, of course, this is one good one. There are benefits in terms of that. We can see, we can feel in our activities, but also have another side that is improvements or a bigger surface for the attackers to exploit. So when we see this diversity in terms of devices, one side, as I said, is, of course, is a benefit, but when we see from the perspective of cybersecurity, this is a very good benefit for the attackers. How can they exploit that? And in another side, it's difficult to manage because since they are very diverse, they have different constraints and different resource capacity. This is also difficult to manage in terms of security. Imagine at home, you have different devices, and how can you manage that? How can you manage the security that you have in your house once it's very different, the necessities and the vulnerabilities sometimes that each one of those devices have in them. In this slide, I put one example of attack that for me was very emblematic and called us an attention for what could come in the next years. This attack happened in 2016 and just raised a flag in terms of what's going on? Where are you going? We going in terms of attacks. This attack was a DDoS attack. I don't know if everyone is familiar with that. Distributed denial of service attack. In general, this kind of attack, they will generate a very high volume of traffic against a target that the attacker wants to compromise or deny the service. And in this case, the target was a server from a company that called Dyn. Dyn is a company that offers name service or mapping the domain of the internet to IP address. And this company just gave support for different companies like Spotify, PlayStation, etc. That with the attack, all these companies came out. So their service, this is based on the mapping of the translation of the name, were out for hours and hours. So you can imagine the financial loss that they had in that time. So they spent like 4 hours or more to address this kind of attack. And one emblematic thing with this attack was that the volume of traffic was never seen before. And this was not the only thing regarding to this attack. The thing also is that the attacker took very, very basic steps to produce and to generate the attack. They spent many days trying to exploit devices connected to the internet with basic things like people that bought the devices and they didn't change, for instance, the default password for the administrator and just connected to the internet. So basic things, very basic. They didn't do very sophisticated attack. They just took very basic steps, and they could, because of all these IoT devices were connected to the internet, they could organize a very huge amount of devices and infect them to be part of what we call botnet. Botnet is a network of infected devices that is the basis for the DOS attacks. And after this attack that was already a record in terms of traffic, volumetric traffic, 1 month after, just 1 month after, there was another attack that just doubled the volume of traffic in that time. So this is why I say that this attack was very emblematic, because it changed the way to see in terms of what's going on. Because it's not a matter of being sophisticated. It's a matter of how to use all the devices and the resources that we have already available on the internet. When I say we, in fact, I'm saying the attackers can exploit without making so much effort to compromise the devices they are trying to infect, or even to generate the attack they want. So this is just came up, and this is just a map in terms of the service that was denied by this attack that I just mentioned. And if we observe, because I said this attack was in 2016, but you could say, oh, okay, it was very specific, very punctual, and will not happen anymore. But it's not the case. Here I just put some very recent examples of other kind of DDoS attacks that followed very few and basic steps as I just described. So these are examples from 2021, 2022, and they are just happening, and it's always the same. This one? So what causes this kind of attack? First of all, there are steps or a vector of attack that can happen or needs to be followed to happen this, to produce this, or to prepare this kind of attack. Like passwords, very easy, as I just mentioned. We have spams, phishing, set of malwares. Thank you so much. And all these kind of very small attacks that can produce a path of attack or a vector of attack that will, at the end, result in these big attacks that I just mentioned to you. And those specific vulnerabilities, they are everywhere. They are in the router that we have at home, Wi-Fi router. They are on the voice assistant. They are on the connected cars, in the cameras, in the devices that we have, the fitness devices that we use, the smart TVs that we connected to the internet. So in all of the devices that we use, they have vulnerabilities. This is the fact, because vulnerabilities comes from the project of the software or hardware that we are building the device, and in many cases, this software or this design of the software hardware, they are not concerned specifically to security. And even if they are concerned to security, it's very hard to have 100% security. I would say that it's impossible just to have this, because as soon as the attackers will evolve, they will find a way to compromise the device or the device or the network. So this is the idea of the general botnet that I just mentioned to you. It's the basis for the DDoS attack. And I would like to just raise some three specific features in the botnets composed by IoT devices. Those devices, those botnets are different from what we know for three specific features. One is diversity, another one is the quantity, And the other one is in terms of mobility, that we didn't have these features before. Diversity means that they are diverse, as I showed you in the first slides. These devices are very diverse. They are heterogeneous. They use different technologies to communicate. They have different capacity in terms of resources, and this makes very hard to protect or detect certain patterns in terms of attacks and botnets in this case. So this is one specific difference from conventional botnets to what I call mobile botnets. Another aspect is in terms of quantity. Of course, here, with more and more IoT devices connected to the internet, attackers have more possibilities to exploit a higher number of devices on the internet. And this is exactly what happened with the example that I gave to you of this dying DDoS attack. So quantity here is an aspect that makes so much difference. I put here very briefly some numbers regarding to this, what we called dot attacks. That means IoT botnets that create the DOS attacks. And you can see here 3,700 DDoS attacks per day. So this is a statistic, and just see here the numbers regarding to the losses, the financial losses per incident that we have, just regarding to IoT botnets. And the last one is mobility. Once these devices are portable, so we can just bring, I just came from Brazil with my devices, I just connected here, and maybe if my computer is infected and has some malware or a virus that can propagate, so every one of you that is connected to Wi-Fi right now, maybe is infected with this malware. So this is very fast, and this mobility makes the spread being very fast. This article that I put here as a reference is an example, and the author show that this mobility brings this propagation very fast. The model they create is very similar what we saw with the virus, the coronavirus, and the spread of this virus, the biological virus in general. So this is another aspect that we didn't have on the past. So for the conventional botnets, where the devices were fixed, we could not increase the propagation of the malware as we have with this feature. And this accelerates things. This makes very fast how these attackers can infect more devices and faster in terms of to achieve their goal, that is generate certain kind of attack. So based on that, I will pass for the second part of my talk, that is, okay, those are the problems. We have all these vulnerabilities. We have those devices connected. They are diverse. They are heterogeneous. They generate data, and the attackers can exploit and evolve very fast. But in another way, another sense, or another direction, we also have the possibility to use the data generated by those devices to protect the network and the devices itself. And one aspect that I believe is the use of artificial intelligence to help cybersecurity. And this was an article at Harvard Business Review. Of course, the idea here was more in terms of administration, but it brings a very good idea in this direction or perspective of using AI for future of cybersecurity. And the title here says that if you want or not, for better or for worse, we need to use AI. Because if we are not using AI for cybersecurity, for sure the attackers are. And they will be more powerful using those techniques. So we are forced to use that. And this is the main topic here in this article. And I have been working on what we call security intelligence. So based on this, all the data that we have, use the data, process the data, generate, or based on the knowledge that we can extract from the data, how can we use to protect the systems, to make them more resilient against this kind of attack, or in general. And another aspect is that the view that we had in the past, based on the CIA, that you should know, or at least those that work on cybersecurity, the confidentiality, integrity, and availability aspect, that was based on a fixed view, a perspective in terms of okay, I will protect my system right now, and if it's protected, then I don't need to worry anymore. This idea is no more valid in nowadays, because things are very dynamic. Things change very fast, and we need to follow this improvement in terms of our systems as well. And again, for this perspective, the data can help, because we are continuously evaluating the system, trying to check the vulnerabilities, trying to check if it is really is still available, or if we don't have any different view or different pattern from the past, or from the close past, and then try to improve the system, and not being reactive against the attacks, but being proactive in terms of attacks. And this is where comes the data science part, because the data science is exactly this process of taking the data that we can generate, process the data, analyze the data, and generate some knowledge that can help in some action. And this is what I want you to keep as main message from this talk, that is exactly this process can help us a lot with cybersecurity. Not only on the technical aspect of cybersecurity, but I also believe that cybersecurity has this broader view of that comes or cross the technical aspect and goes to political, social, and geopolitical aspect in terms of cybersecurity. And you that is interested on cybersecurity, you should understand that cybersecurity is not only technical, it's also administration, it's also political, it's also in terms of lawyer, if you want to work with. So it's very broad, and you have spaces. And we need, because the market is requiring people and professionals in these different aspects or axes in terms of cybersecurity. And so this is one point. And when we talk about data science, it can help, and can really help in all these axes of cybersecurity. But we talk about, nowadays we talk a lot about data science, and what is really new, because when we see this process of, or this path of processing data, taking the data, generating some knowledge, it's not exactly new. Why we talk about data science a lot in these last years, for instance? We have two main aspects that have attracted the attention, or made it possible to work with this data, or this volumetric data that we have. One is the availability of the data. With this quantity of the devices that we have, we could produce more, and we can store more with the new technologies as cloud computing and cloud that we can store the data. We have the data that is available for analysis. And before was not exactly the case. Of course, we have more power in terms of storage, and this is another point. But also we have some more computational power for process, for analyze the data that we have and the possibility to generate or to result in new knowledge that we could not go before. So it's just one example is just like genetic analysis. We could go further because we have more processing power that we could not have before, and this makes us to new knowledge that, of course, we could not achieve in the past. And this is the same for cybersecurity or data science. And all this evolvement in terms of resources and the data that we have available makes us to a new step or another step, higher step in terms of knowledge that we can generate with this analysis, data analysis that we have today. We have different types of data. The structured data that is very difficult to achieve or to have as input for cybersecurity. In general, what we work on is on unstructured data, and in general, unbalanced data, because when we analyze, for instance, a network, in general, we will not have talking about attacks, for instance, we have like 100 days of data set that there is no attack, and 1 day with attack. So this makes the data very imbalanced, and this is the reality that we need to work. But in another sense, in another hand, this is the worst case to make the techniques to work with this kind of unbalanced data. So this is a challenge that we need to solve. And it's always the same thing, how to deal with that kind of unbalanced and unstructured data to analyze that basis, that input to give us some knowledge about cybersecurity. So when we come to defense lines, I like to show this taxonomy because at least we have a better view of what we have in terms of solution for cybersecurity. We have like the preventive defense lines, the reactive defense lines, and an intersection between security and resilience, that is the tolerance. So here we have, I could give you many examples of each one of these groups, but what I want you to call the attention here is that there is a new point here that is the predative defense line that is not exactly, we didn't want to wait to the attack to happen to address the attack. So the idea here is to try to forecast the attacks, try to understand or anticipate steps of the attacks in order to have more time to address this kind of attack or threat in the network. I will give you an example, and this is proved in some models that you can find in the literature. If we take again the DDoS attack and we apply, for instance, intrusion detection system, that is a reactive system, what will happen? Will happen that the target is already overloaded in a certain way, and again, in that step, you start to detect the attack, but the attack is already happening, right? The attack is already overloading the target. So there's no much time to the administrator to do much with the attack in that case. And mainly, if we consider this new context of many IoT devices, a higher volume of traffic, the time that we have to, or the administrator could have to do something or to detect the attack and do some action against the attack is very, very small. So it doesn't make sense to work on this step, mainly for the DOS attack. But if we try to anticipate the steps, and if we try to observe the formation of the botnets, then the administrator will have some chance to protect the network or the system in a general way. So this is what I call this predictive defense lines, where we will try to anticipate these steps of attacks in general. I gave you an example for DDoS attacks, but could apply for the attacks as well. Of course, here we have the other examples or the other techniques in this group of preventive defense line. But I will not go over these other groups because they are very known and very conventional. I put this figure here just to emphasize the researches that we are going in the direction of anticipate the steps of the attacks. And this is what we have as new in terms of research. So here I put some very fast, very few examples of results we got in this direction. Here is two very short shots of data set of a network. Here are the size of packages. Here is a window of 16 seconds. Here is another window with 16 seconds. And here what we wanted to say, to observe is that this part, this window, was one time before the beginning of the attack. When I say before the beginning of the attack, it's before the DDoS attack overload the target. And here you see is exactly the point where the attacker start to overload a target. That means that the botnet was already prepared, was already in place, and the botmaster gave the command to start the attack itself. And we see clearly the difference in terms of packages, the number of packages, and the size of the packages that we have. This is a very basic feature that we have in the DDoS attacks. The attackers will use packages with the maximum package size in order to overload the bandwidth. And this is exactly what happens here. You see the number, almost all the packages in this case from the beginning of the attack is in the maximum size of it. So what we started to work was in these phases, as I just mentioned to you. And in these phases, what I highlight here is that we already have some peaks of sending some packages with the maximal size. And in these cases, what I want to highlight is that we have some signs of the botnet that was being coordinated or installed, and they are testing to send these packages when the botmaster could give the command to start the attack itself. So we started to identify this kind of signs inside the traffic in order to anticipate the attack itself. How we did that? We worked with some techniques. I'm sorry, this is in Portuguese, but I can imagine that you can understand. We have first, let me just explain what we did. We took the data set, we analyzed the data set, and we tried to create a kind of network, as you see here, a graph, that shows the interrelation between the devices. And as much as is the access between each one of the points, pairs of points, higher is the interaction between these devices. And this shows, at least in our case, we started to interpret that as some botnets being created, and they are communicating with some kind of botmaster. And as much as or stronger is this kind of edge, higher is the communication and interaction between those nodes. So this is a situation where we didn't use any threshold to maybe take only the top 10 or top 5 more interactive points or devices in this case. And this in this other side is the case where we put some threshold to take the top 10, top 5, in this case, the top 10 of these interactions. So this is the idea we took as basis here a technique from signal processing area. We this research was done together with some fellows in Carnegie Mellon University, and they were experts on signal processing, and we were working on this cybersecurity part and applying that. And their technique tried to take some techniques from signal processing that you know that is very fast, because they need to be fast online, to data, to how to analyze data. So they took as basis the signal processing techniques and tried to create techniques, but now for processing data fast. And this is what we want, because once we have a very high volume of traffic, we need to be fast to analyze the data. And if we use the techniques that we have now, even if we take like artificial intelligence or machine learning techniques, they will not be very fast. And we need some kind of close to online processing to work with this kind of problems that we are trying to solve here. And this was the idea. We took as basis this transformation they gave, that was their domain. That means to adapt the signal processing techniques to data processing online and apply for cybersecurity. And this is some results that we got regarding to this research that we have done. Of course, we can have, and we need some, at least at this point, we still need to have some interpretation from what we are seeing, because the interactions could be just genuine nodes and not exactly attackers. But at least it will come up with this view of interactions, and the administrators can investigate those nodes that are communicating and understand or try to apply other techniques to understand what's going on. So this is the main idea of this work. We are also doing some other works on applying artificial intelligence. Of course, we always try to go out from the norm, from the traditional application of this artificial intelligence. And in this case, what we have seen is that we have a lot of challenges when we try to apply machine learning techniques for this context of cybersecurity. For instance, we have some diversity in terms of protocols. We have diversity in terms of attacks. We have different architectures for the botnets, for instance. And this makes very challenging. And this diversity that we have in general, and now the volume of traffic that we have, and the improvements very fast for malwares, etc., makes the scenario very dynamic. And if we apply these techniques, the approach that you see on the left, that are traditional techniques, that means we use methods to detection, or you need to calibrate some parameters. They are fixed, they are static, and will maybe work on a window, but in the next one will not work anymore. And we don't want that. We want something dynamic, because this changes very fast. And we don't want that to rely on some person that will go there and calibrate the approach, because we don't have time to do that. So those, of course, some are characteristics of approaches that we have now, but in the other side, we have this challenge that we need to solve. So we have doing some work on that sense, And one solution that we came up until now is to use what we call autonomous machine learning. That is a kind of technique that will try to test and verify which one of the technical, of course, still we have some parameters that we need to calibrate, but we need to have a set of techniques that can be used, and the system itself will select that one depending on the specific scenario they have in that time. So it's we would say that is an advanced step regarding what we had in the past, because on the past we needed to have someone going there to calibrate. Now we have maybe a set of techniques that can be applied, and the system will select the best one in that specific case. But of course, we still have many other challenges that we need to solve, and there are a lot of space for research in that sense. So this is just to point you where our research was positioned in terms of AutoML technique, botnet detection, and another technique or theory that we have used is concept drift detection. I don't know if you are familiar, but also based on the traffic or the data, we can, based on this concept drift, we can observe where the data distribution starts to change the pattern. And we use that to trigger the AutoML system to calibrate again, or to recalibrate which technique could be better for that specific scenario they are seeing. That can be in Windows, very small. This is another point that need more research to define what is the time of the window. But based on that, we could have better results that we got in the past. I will not go over this architecture, but this is a general view of the system that we have proposed. So we have a phase in terms of data pre-processing, the drift detection here. That means when the data distribution pattern changes. Here is the pipeline optimization. That means that we have a set of solutions, and the system will decide which one is the better for that specific case. And then we will classify the data to see, to detect the botnet itself. We have performed this, or we have evaluated the system using different data sets. Here I put just one result just to give you a flavor of what we got. This is just generic parameters of the data set that we have used. But the main result that I want you to see is that here is a situation where we have, the most important here in this graphic is this bot prediction. Okay, this is the curves that we need to see. Here is the precision of the system. Those steps or those windows here that have these dashed lines means that they are windows in which we have attacks on that. And this means that, or botnets in this, or activities in this case. And here is the result of the botnet detection here that we have. In this case, we have some results regarding to what we call semi-supervised results, where as you see, the precision in terms of bot detection is not so good. But when we started to use this automated or AutoML-based approach, we could improve the detection of these bots in the different window where we had the botnets. So this is the main aspect that I wanted to show you. these are the different pipelines. It's just to show you that the system, for instance, in this window, the system have selected. So this is what I had prepared to you. I'm open to questions. And thank you so much.
Many thanks for the presentation. I would like to ask what kind of vulnerabilities have been detected during the experiment, and if there is a pattern, because to me, it's not clear how AI will play a role in cybersecurity. I mean, I know that there are many companies that offer like Cisco or Oracle or many other companies that have been offering the service of cybersecurity. But I would like to try to understand what is the contribution of your research to the knowledge, to the current knowledge in the topic.
Yeah, regarding to the vulnerabilities, well, for this specific work that we are that I have we assume that the vulnerabilities exist and they will be exploited by the attacks when they infect the devices. So we didn't go in the level of computer security. We go in the level of network security. That means that we take as basis the network traffic to analyze the network traffic and then see how to anticipate this kind of attacks that can happen against a target. In terms of contribution, one of the main contribution is to raise this aspect of anticipating. That is important. Anticipate attacks, anticipate signals that can show the administrator or the network in general to see that may have an attack in the next feature. So this is one point. And another point is the autonomously part. That means automatize the solutions, mainly for this classification part. But still, all this is in the network security level, not on the computer security level. But we also have some works that I didn't show today. We have some works in terms of privacy that goes a little bit in the direction that you are saying, but also we took as basis the network flow to analyze and see if the network flow is leaking any information that the attacker can use or can exploit. So this is a kind of vulnerability that is data loss that we have been working, but this is another project that I didn't present it today. But we also have some research in this direction. Another point is that when you say regarding to vulnerabilities itself, there are a lot of databases like CVEs that list the vulnerabilities in the systems, I mean in OS level, on computer level, that we can use. The majority are for the conventional devices, conventional networks. And another direction that we didn't exploit it too much, but the idea was to take as this analysis that I showed to you to see these leaks and anticipate CVEs that could help happen in IoT devices. So this is something that we have worked for 2 years in a project, and we now are continuing, but in the level still of trying to identify these leaks.
Hi, thank you for the presentation. Very interesting. I have a question in terms of cybersecurity. I've seen that there is a lot of challenges in terms of software, but I'm seeing that many companies are also investing in terms of hardware. So my question is there a way that in a combination of both parties, I mean software and hardware, we can increase the level of cybersecurity?
Yeah, in fact, this is the way that should be. But we understand the difficulties to work with both of them together. And, but I see some efforts going in that direction, but not in general way on specific companies, because we need some resources, or we need much resource to work on both at the same time. And needs a very big compromise on how to design the hardware until the software. And we know that the teams are segregated in certain aspect. But what I see is that in the future, this gap will be smaller than we are today. And there's a culture that we need to pursue inside these companies, inside the institutions in a general way.
Thank you for the presentation. My question is, what kind of algorithms you used for the predictions?
Yeah, I heard the question. Yeah, thank you. In this work that I showed to you, we went to some very simple thing. We used just statistics to analyze the data. So we took statistics and some what is called signal warning systems. If you look for, you see in statistics, they have some signals. Signals in their terms are statistics metrics that they have been developed not for this area. They have developed, for instance, for hurricane or for temperature, for financial market, for things like that. So they developed those metrics just using statistics, autocorrelation, variance, things like that. Very simple. And they created those signals. Again, signals for them are those metrics. And what we did was to adapt those metrics for our case, for cybersecurity. So this is what we did. So why we did that? Again, based on the necessity to be fast in processing the data. If we go for something that is very load, very heavy to use, to process, will not be fast enough to have the results and give the time to the administrator to make some action to prevent the attack. So this is the main rationale that we made in this case. In the second results that I showed to you with the graph, we went for this signal processing-based techniques to data. But the conclusion that we achieve is that despite we had good results, they are very heavy. And if we would put this technique in place, it will not work for our goal because it will take so long to process all the data because we have many calculations with matrices and it's very heavy. So will not be enough.
Well, first of all, thank you for the presentation. It was very interesting. Well, my question will be, right now exists the Google Platform services. So how much do you recommend it since Google Platform makes everything for you? The IA intelligence, the data settings. How do you approve it and how is it more better against other tools?
Do you mean to use the cloud or the processing in Google?
Yes.
I cannot evaluate what they use. We try to not use those platforms. Of course, sometimes we need to do this collab and all these platforms. They have to machine learning analysis, but we try to not use exactly those specific platforms. We try to use our servers to process the data.
Okay, thank you.
¿Hay más preguntas? Bueno, muy bien. Muchas gracias. Vamos a presentar para informes. Vamos a presentar dónde nos pueden localizar a los encargados de ComSoc. Somos su servidora Araceli García como presidenta del capítulo de comunicaciones sección Guadalajara, o con el vice chair, que es Steven, que está acá al fondo, es el maestro Steven Ángel Echeverría, y esos son nuestros correos donde nos pueden contactar. Okay, el mío es muy sencillo, es Araceli Triple, y el de Steven, pues es su nombre, stevenangelecheverría@intel.com. Bueno, vamos a dar ahora paso, le dejo el micrófono a mi compañera, la doctora Mildred Alcaraz, Chair de Women Engineering, para pasar a la siguiente parte de Women, y estaremos aquí. Al terminar, los vamos a invitar a un break que va a estar en unos momentos más acá afuera. Nosotros les indicamos. Muchas gracias. Adelante, Mildred.
Bueno, buenas tardes a todos. Voy a hablar en la introducción, la voy a decir en español, porque la doctora Michelle quiere practicar su español. Ok. Primero que nada, agradezco mucho que estén ustedes aquí presentes en esta plática y pues a la doctora Michelle por acompañarnos. Ha sido un día que hemos disfrutado. La dinámica de esta pequeña plática que vamos a tener es más para conocer la vida profesional de la doctora Michelle. Entonces, yo voy a iniciar con una pregunta y enseguida ustedes, si quieren hacerle alguna pregunta en particular, la pueden hacer también. Doctora Michelle, what do you consider has been the biggest challenge you have faced in your career as a woman in engineering areas?
Well, didn't face a challenge for being women. I know that happens, but the main challenge that I had was really, I think, challenge that every researcher will have in the beginning. That is how to take or how to achieve fundings for the research, how to have space to be recognized and then have some credibility to have fundings for your research. But I think that this, any researcher will have along the career, mainly on the beginning. So I don't think that I had one specific thing that was challenging because I was women. I always had very much support from my colleagues, my male colleagues, even when I was in my PhD, on even my undergrad time. I always was very comfortable with my friends, and they always helped me a lot. So they supported me and gave, but I didn't felt any difference because I was a woman. I would say that I didn't face any specific challenge for being a woman. I was generic challenge for researchers in general. I mean, of course, PhD time was very tough, but was not because I was female, was, was in general, yeah.
Yes. And it is known that we are a few women in these areas. And what would you do to incentivize the participation of more females in these areas?
I try to support a lot of females. I had a lot of female students. Maybe when I see the department and of course, they have identity because I am a woman, and they come to me and try to work with me, even undergrad students. But I try to motivate them in different ways. Try to push them, push them in the sense that motivate them, saying that they are capable in the same way that anyone else. I had one specific situation where my female student she just arrived on the master, and she was moving was the first time that she was living alone and moving from one city to another. So she was very vulnerable in that time. And I remember that she was crying, and I was there, and I said, oh, well, we just talked. And in the other day, she was very motivated, and she concluded the PhD. So she passed 6 years with me. So, and sometimes it's just a matter of not feeling well because, I don't know, because it feels that it's not the place to be there. And it's not the case. Having someone there to say is important to motivate and continue in the path. So I try to do that.
I think it's important what you said, that you have faced challenges, but because the area is challenged. So this is important because maybe there are out there some girls that would like to study science, math, or engineering or something, but for somehow there are certain I don't know the correct word, but maybe like kind of fear, maybe not fear, but there's not so much confidence because they know that they are going to find many boys, and maybe it's not very comfortable, or they are not used to be around boys. Maybe that's one of the main points. So I like to thank you for your answer. And I don't know if anyone here in the audience Have some any question?
Yeah. It is not working, but we were here.
Okay, I'm gonna stand up. I have three questions. The first one is, at what age do you start getting involved in STEM? I mean, what influence did you have to be interested in STEM? The second, why did you choose a research path instead of working for a company? And the third one is, if you consider that nowadays women in science, because we have had women in science for a long time. I mean, Marie Curie, Lisa Meitner, but Lisa Meitner she was not awarded the Nobel Prize of Chemistry because of her Jewish background, because I think she was Polish. You think that nowadays still remains that discrimination against women in science?
Yeah, I will start with first one, of course. My history in STEAM is a bit strange in two sense. First, I always was very attached to math and physics, even on the high level school, and I like it to math and all these solutions for problems. Even the boys were together with me, and we worked together to those things. But at a certain point, I decided to be dentist. So I didn't want to go to physics or math or anything. And my head was, I want to be a dentist, and I did, in Brazil, we need to do a kind of, it's not a context, but we pass an exam to go to the university, and you need to decide what course you want to follow. And there we had two universities in my hometown, and one was I applied to be a dentist, and another one I didn't know what to choose because they didn't have dentists. And on the last day to make the registration, and I check it there and I say, okay, I will do computer science. And of course, I didn't pass on the dentist course, and I started to do the computer science, and I like it. And I said, okay, I will stay here, and I just finished my undergrad, and then I went to the master, so I moved for another city, and that time was very challenging for me. I don't know if it was, for sure was not because I was a female, but because of all the changings on my life, like going out from my parents' house, living alone, and in another city that was different and big, because my hometown is very small. And in that time, I was like scared, maybe. And I never thought to give up, not because, not at all, but I failed in some exams and some courses that I was taking. And it was not because of my capacity, but emotionally I was devastated. And in a certain point, I had one friend that was until today, and he told me, helped me to pursue, and then I finished my master. And then I went to the PhD, so I mean, it was like a common path to go. I didn't think back what I was doing. I think it was already something that I had the vocation to do, like maths and something that I like it, but maybe I didn't have someone that could advise me that by my profile, it would be better to go for a STEAM course than another course that was not in that scope. So this is one point. The second question was regarding to the academia and industry. In my undergrad, I really fought to go to industry. I had some opportunities to go, and this is one thing that I always say to my students. Don't try to enjoy your period in the undergrad, and if you have the opportunity to go to the master, go to the master and do your master, because after you have so much time to change if you want, because we have also this in our mind. Okay, I will take this path and I will never change in my whole life. But when we look back, 4 years on the undergrad, or more 2 years maybe on the master, 6 years, and we compared for 40 years of career, it's so small. So take the course and enjoy that path. It's the best thing that you can do. And in that time on the undergrad, I had this dilemma to follow to the academia or go to Xerox in that time. That was the opportunity that I had. And I was really like, oh, the salary is good, I could go there. But I think I would not be, I would not feel comfortable to work on the industry. One aspect that made me to choose the academia is the flexibility to explore new topics, like these things that I'm doing. If I was working in the industry, I would not do that because I would need what they wanted me to do. So this was important for me, this flexibility and the freedom to work, and of course the possibility to know to meet many people. This is also another important aspect that brought me to academia, and all this conference and meeting people and exchanging the ideas. This brings something back that motivates to continue in the academia. I never thought again to go to industry. I thought maybe to stay outside Brazil when I was in France, for instance, or when I came to the US. I thought to not come back to Brazil. This was one point. But again, I think I make more difference even with the difficulties that we have in terms of research in Brazil. I would make the difference there. So this is why I come back. And the third one was regarding to the discrimination. Recently, I did a panel. I organized a panel, and I make a history, women in science. And the history is interesting because we see, like in the Middle Age, where all the universities started to be built and established, the women have been excluded from all the science. And in that time was maybe when all this discrimination started, because we were out of science. It's true that in that time that you are mentioning, like Marie Curie and all these improvements and all the Nobel Prize that we have as examples, was maybe some exception, but still today I think that we have some kind of discrimination. I was just telling during the lunch that these companies have these programs for women, but we know that they are not doing the social thing. I mean, they say they are doing the social thing, but at the back, they are still exploring the idea of women, because they know, and that there are some statistics that women produce more. Women generate more resources. And they pass this social idea, but it still is a kind of discrimination, because they are just thinking in their profit and not exactly the social benefit that can brings. And so, yes, I think there is a lot of discrimination. I am glad that at least in my knowledge, I didn't have any kind of discrimination. Even in Brazil, that is so tough for women. There we have a kind of, it's not exactly a title, but it's like a NSF fellow to receive a kind of prize when you are researcher and you increase the grades. Just to receive this fellowship is very hard, and maybe the percentage of women that have is 1% of in all the areas, not only on STEAM. And even that, I didn't have too much. I didn't have discrimination to be included in this aspect. I see that was fair inside of all the selection. It is, of course, it's not so fair, but it's not so fair for everyone, not only for females. But still, I didn't feel any discrimination for being women. And I see sometimes with some colleagues that are male with more discrimination than what I had. So, but I know that this exists. And one thing that I could complement what he said is that also the way that we behave. I see some female that arrives in a room and they put the head down and behave like that. So even if she was male, she would be treated as someone that is not included. Maybe they excluded themselves more than the people that is inside the room exclude them. Sometimes this is what I feel. And this is a kind of culture that we need to change with education. It's not the university, it's not the place you are in the meeting, is something that maybe comes from home. And be used to be with the boys.
Being comfortable.
Yeah, what I see is that many times female just group themselves in one side and the boys in the other side. And I never followed this. I was in the middle of anyone. But this makes this segregation. And this makes after, when you are in a class that you need to face the male, makes you uncomfortable because you are not used to play with when you are a child.
Thank you. I think many of the students here felt like you about being outside of her home, because many students came from other cities around here. Maybe that change, well, I know that change is difficult, the adaptation, but thank you. I don't know if any...
Don't try to change the society. Just change your mind. It's enough.
Yeah. Thank you very much for being here. If any of you are interested on IEEE, en IEEE, voy a cambiar al español. Si alguien de ustedes está interesado en conocer más sobre el IEEE, hay la Asociación de Estudiantes de IEEE en ITESO, hay una rama estudiantil de ITESO, si quieren formar parte, pueden escribirnos. Igual también hay una para las mujeres en ingeniería que no está hecha especialmente para las mujeres, pero los objetivos es tratar de hacer crecer la participación de las mujeres en la ingeniería, pero está abierta la participación de todos. Todos sean bienvenidos. Muchas gracias por estar aquí.
Ahí nos agradecemos a todos su presencia y de nuevo muchas gracias al Departamento de Electrónica, Sistemas e Informática por su valiosa colaboración, a la coordinación de redes con el maestro Carlos González Durón, a Luis Fernando de la Ingeniería en Ciberseguridad y a todos los demás compañeros del área de posgrado y otras áreas también de la universidad, como son la Oficina de Sistemas y la Ingeniería en Ciencias de Datos del MAF. Muchas gracias a todos. Y bueno, para agradecer a la doctora Michele Nogueira su presencia, tenemos un pequeño presente que le hará entrega Itzel, que es miembro de la rama estudiantil del IEEE ITESO. Muchas gracias a todos y los invitamos a pasar aquí a la terraza. Hay un refrigerio como un agradecimiento a ustedes y próximamente les anunciaremos los siguientes eventos que tendremos por parte de IEEE. Muchas gracias, bienvenidos y los invitamos a que se afilien también al IEEE. Muchas gracias.